This video is for educational purposes only. It is not sponsored, endorsed, or affiliated with any brands or manufacturers featured. All products shown in this video are owned by me, and any trademarks visible are part of the product being analyzed. In Chapter 1, Episode 1, we will learn about the principles of miniature circuit breaker. First, let's define it. Second, we will observe its operations and how it works. Third, we will list its general applications. Miniature circuit breaker is abbreviated to MCB, is categorized as an electromechanical device because it acts mechanically due to electrical behaviors. This is a common symbol used to describe it. The electrical behaviors are translated either thermally or magnetically, forcing the mechanical operation of the device, which is called tripping. Here are other symbols used to describe protective devices used in electrical drawings and schematics, also used in electrical design softwares. Now let's see how MCB operates. One of MCB operations is called overload protection. Let's simulate a circuit consisting of AC electrical supply, providing live line and neutral, which is called single-phase system, or one-phase from three-phase system. Load is connected to the supply forming a circuit. This load draws 8 amps of electrical current. In order to protect the circuit and the load is connected through MCB rated at 10 amps. The MCB is closed to connect the circuit. Electrical current of capacity 8 amps, forming from charges in the conducting lines moving in an alternation manner. The MCB is rated at 10 amps and is conducting at 8 amps, so it will not trip and open to protect the circuit. Another load is connected parallel to the circuit, draws also 8 amps in its branch circuit in alternation manner. The MCB now is conducting at 16 amps, which is above its 10 amps rating. Its thermal unit will start heating and expanding internally to activate trip mechanism. When trip occurs, the MCB will open the circuit and stop the flow of current to prevent wires from overheating and prevents fire. The thermal unit will cool down back to its original state for another tripping cycle. Another MCB operation is called short circuit protection. Short circuit occurs between line and neutral or earth in single and three-phase systems, also between line and line in three-phase system. In this example, we will simulate a short circuit event between line and neutral. The location of the short circuit must occur at the output side of the MCB, so it can detect it. Undesired connection occurred between line and neutral. As you can see, the operation is completed instantaneously, so let's review what happened in slow motion. When line and neutral get in contact, the load now is the conducting lines having low resistivity, thus produces a high current capacity along them. The magnetic unit in the MCB detects the high amp capacity and activates instantaneous trigger of the MCB, forces tripping and opening the circuit to stop the flow of current to prevent conducting lines from overheating and prevents fire. Another MCB operation is called isolation. Isolation is simply switching the handle or knob to off position, thus cutting the power between the supply and the load. When the MCB is switched off, the flow of current stops, but in fault-free conditions. This operation allows maintenance for the load, conducting lines, and terminal connections. MCBs are used for protection in different applications. They are installed in distribution panels, like surface or flush panels, or could be enclosure panels. These panels are used to protect residential loads, like houses and apartment buildings, or commercial loads, like hospitals and malls, or industrial loads, like factories and machines. In the next episode, we will identify the components of the MCB.